Well, thank you, Matti. Welcome to Microsoft Teams, Teams Nation, our Microsoft Tech Community event. As a reminder, everything is recorded. If you're not comfortable with that, then you probably should not be in here, but in case you want to say something, or just be quiet. But if you say something, it will be recorded. Just be aware of that. So my name is Andreas. I have been dealing with all sides of technologies since the mid-90s. Already worked with VR at that time, but then many years just enterprise stuff, enterprise consulting, BizTalk server, all those things that nobody sees. It does magic things. And then I worked on scalable systems. But around 2013, 14, I tried to rediscover my passion again to work on a geeky technology and work with Kinect for Windows. And then started hearing about HoloLens and got hooked on that. And also now try to often tell stories combining a lot of innovative technologies for bigger things. Yeah. So let's do a little like level set, or like what have we been talking about, or where are we coming from? Those who have listened to my talks before have seen this slide probably, but I think it's important for level settings. All those things are not so far away, like those first like mechanical computers, or this computer here that was still in the 1930s was where you would actually, for 40s actually, where you would program computers by connecting patch cables. Yeah, so you would implement logic by patching things. The punch cards were a big innovation step to be able to interact with machines. Suddenly you could change programming almost on the fly. And then we had the integrated terminal with a keyboard and a screen. And now the biggest thing is most of our lives today are still interacting with a mouse, but the mouse was already invented 1963. And the first prototype of a integrated terminal with a graphical user interface and a mouse was introduced in 1968. So that's like 54 years ago now. Similarly, the touchscreen is also not a new invention. The touchscreen is from 1965. And here, I think the first Simon smartphone was, I forgot the year now, 1990 something, 1992. So didn't really take off, but it was the first theoretically smartphone that could have installed apps. Didn't have an app store, though. And what is still the same is that for most of us, we interact with those metaphors, right? We interact with flat screens that look nicer now, have great shiny pixels. Some of them are really big, some of them are really small. But in general, almost all our work is in 2 dimensions, interacting with a 2D screen. Yeah. Now we could go to the 3D screen, all right? And like a catch-all terminology for that is extended reality. And there's some interactions paradigms, how you could interact with a 3D screen. Yes, one of those is gaze. What do we look at, either with eye tracking or with head position? Like think about it as a laser pointer duct taped to your forehead. Or you could understand gestures, things you do with your hands or with your body to express what you want to do or to point at something. Then we have voice commands. That could be either specific commands like open app, close app, or it could be more sophisticated things where it really understands or try to understand what you're saying. Think about OpenAI, GPT-3 models. Things are getting more and more advanced over time. Controllers play still a role because sometimes those gestures are not precise enough for detailed movements. So with controllers, you can sometimes augment things and let's say my motion now, if you click a button, only equals to 1/10 of my physical motion in a virtual space. Then we have concepts that we will look at into what is like related to spatial mapping, which is basically a 3D representation of the 3-dimensional world we live in. Another important thing is spatial sound. That is, that sound is produced accurately for your ears depending on where something is. Like most 3D frameworks, environments like for Oculus Quest 2 or HoloLens, they have a library that either comes with it or you can install extra. That makes it really easy. Basically, you just give things 3D coordinates and play a sound, and it will automatically play it correctly for your ears. It is relevant because user guiding is quite difficult in 3D space. If something is behind you, how do you tell a user about that, right? Of course, you have to think about accessibility. Not everybody is able to hear 3D sounds. If you have only one ear, you can't do that. Or if you're hard of hearing, but you could also use arrows and so on. But it's an important part of user experience. And then a concept called world coordinates. What are world coordinates? It relates to spatial mapping. It is basically the ability to locate objects in 3D space and have a common understanding of your virtual environment related to a real environment. Yeah, and if you are completely in a virtual reality world, you wouldn't have necessarily this mapping. If you like seated and play with a controller and something like that. But if you're in a virtual environment like with an Oculus Quest 2, the Oculus Quest behind the scenes actually also uses things like spatial mapping and world coordinates, even though it may not display it to you. You can toggle a see-through mode, but it needs it to be able to translate your movements to the virtual space. Okay, this is just a very quick overview about what we have, right? Now let's look at some of the concepts of MetaVerse. First of all, MetaVerse is catch-all term at this point. I will not go into the literature behind it or who invented it at this point, but how do I think about it in this concept, right? In a MetaVerse, typically you have several concepts how you interact with something. No matter how it's rendered, if it's three-dimensional or if it's like a game that you see that is 3D rendered but on a 2D screen, or assuming, for example, you open the AllSpace VR app and you don't have VR, you can open it in 2D. You have a concept of world, space, and location. That means a model of what you're seeing around you, things that are displayed there, then some understanding of the spatial coordinates in there, and the concept of the location where things are that matter to you. Then almost all metaverses need somebody to interact with it, and we call this, like, the concept would be presence. Presence is similar to Teams, would be when we also have the concept of presence there. The presence indicator is typically only like busy online on a call. In a metaverse, it would be a little bit more sophisticated. It would be like, where are you? And what are you pointing at? Basically, it's related to your coordinates and how you're moving and so on. Then you have the abstract concept of state. That means, in one sense, like the state, most metaverses, or in metaverse, typically we think about that it needs to be persistent. It could be related to the real world, even, like you would want to persist virtual objects maybe related to a real world. That could be just like an AR tag next to an AR coffee displayed next to the Starbucks, right? It could be like that. Or it could be just that you save the whole virtual world and come back to it. And potentially that another person also joins that same metaverse, interacts with it, and sees the same thing. And with that comes the concept of synchronization. The task, how do you deal with that multiple people see the same thing? That's very, very common in multiplayer gaming and massive multiplayer gaming. It's really hard to solve. And most of the know-how of that actually comes from the gaming industry. Communication interaction is related to synchronization in some sense, but is more specific, and it may have like an audio stack, like similar to Teams, and have more general purpose networking concepts, or that could be also implementation of queues, so things how can you interact, right? And note, this is all like concepts that would be relevant for people building applications, not necessarily using them. Then we have, what is representation? Like, what does it mean to put something in the metaverse? That could be 3D models or the avatar that you have. And again, we will not go deep into those things in this session. This session has a few niches of the metaverse. Rather, we will get to that in a little bit more. So it could be 3D models or the avatar that you represent yourself with it. You can design what you want, and typically Each metaverse currently still has incompatible avatar systems, but often 3D models have a standard representation or file format that you can import or export in many metaverses theoretically. Then, of course, it could be just abstract metadata. So metaverse doesn't necessarily mean that everything has a 3D model. It could be just, let's say, weather data. Like you want to synchronize a virtual world with your real world, and you use the weather information from the real world to render weather in the virtual world. And similarly, the concept of digital twin, be it from Internet of Things or from any real-world object, may have some types of virtual representation. This could be anything from configuration data to, again, 3D representations to just a picture of it. And finally, a big topic is cross-world interoperability. A big vision of the metaverse is that it's not just a walled garden. Like a lot of metaverses that are called by, let's see, by at least by the people pushing it, some people say all space VR is a metaverse. Yeah, you could argue it has some aspects of it, but you cannot take your avatar in all space VR and go to Facebook Horizons, for example. So metaverses currently, unfortunately, are not interoperable yet, but that's one of the biggest challenges to solve in that whole industry. Now you may ask me, what about blockchain crypto? Because at least for me, I have metaverse in my LinkedIn profile. I get about 5 to 6 requests every week where people want to talk about metaverse, and in fact, they want to talk about blockchain crypto. One of the applications of blockchain crypto or metaverse could be to, similar to non-fungible tokens, to, let's say, distinguish ownership of a digital asset and have it independent from a central repository. Meaning, for example, you may have virtual property and you say this space, this coordinate in the metaverse is mine. Is it useful or not? That's a different question. But a more interesting application may actually be in the whole area, not like in payment systems and so on, but it could be, but in the whole question of interoperability. Because how can we make metaverse interoperable? Well, you need to solve, of course, some protocol to make them interoperable, but then you also need to solve questions like how do you prove who you are? How is your avatar associated with who you are, and so on. So in that field, I see potentials for blockchain and crypto, for example. The next is I want to show quickly how does Microsoft Mesh relate to all of this. This was introduced about a year ago, actually. I think it was March 21st last year at Ignite, the virtual Ignite. And they showed us all this here, right? So we had some concepts like immersive presence, holographic rendering, multi-user sync, spatial map, and all those things that are various capabilities to build metaverse type applications. So it could be the HoloLens Mesh app. This is basically a collaboration with HoloLens. Could be Allspace VR, could be Microsoft Teams / Mesh for Teams, and then some other applications, right? Now, the unfortunate thing is nothing much has happened, to be honest, since last year in this field. As we know that Microsoft is working on Microsoft Teams and Allspace VR is getting some more traction, it seems also. But a lot of those things that have been announced or that have been working on, for example, here immersive presence, they were looking at SDKs, how to make representative avatars, and those are interesting things to solve in that regard, right? If you have an avatar in your own app, how do you make sure it looks natural, that it aligns to your physical body movements as close as possible, and so on? So you could imagine having SDKs for all those things. How do you do holoportation? That's basically holoporting yourself with some type of camera, 2D or 3D camera systems into 3D space, and so on. Unfortunately, all those things really, we don't have much in that. We have Allspace VR currently. We have Mesh for Teams, which is coming up, and that's what we have in the Microsoft ecosystem currently. Yeah. But we have a few things that you, in this field specifically, and to some regard in this field, and so in this field here, in this field, where we have some platform capabilities. So let's look at that briefly. Yeah. So first of all, let's talk about briefly. That is not a cloud topic, but what is spatial understanding? If you want to interact with a 3D environment, and that's important for any type of real metaverse, really, that interacts with physical space, you need to solve a few things. Like maybe you have concepts of location or anchoring, so you need to understand like moving, you may, depending on where you move, have a heat map. How often did you look at something, or where were you? You could have things like following breadcrumbs. Think about, you would have a pet following you. It would work in a way potentially by following like Hansel and Gretel style, the breadcrumbs, virtual breadcrumbs that you would drop. And then you have a concept of anchors. We will get into that a little bit more. Anchors is a way how you fix something between virtual space and real space and find it later on. And then you can work on the 3D representation of your environment. I call it work the mesh. You could optimize it, make it look nice, and standardize it, or you could find things, find a wall, find the floor, find free space. So what is a spatial anchor? I will not read the whole thing. So basically, it describes a point in space relative to your surroundings by distinguishable visual features, right? On a HoloLens, that would work with those little cameras on the side of the HoloLens. If I hold it in the camera here, that behind the scenes track your environment and set up feature points that represent your environment. Yeah, so it can be used to align coordinate systems and find things again. So if you put a hologram in the 3D space, then it will be stable relative to the things that your physical device observed. AR tools like the on an iPhone, the AR kit an AR core on Android have similar concepts for the respective platforms. You can also do other things like using physical markers and so on. Now, what is a spatial mesh? This is a bunch of triangles describing the geometry of something. Like on HoloLens, that would be what the depth camera has seen. Depending on your 3D, on your AR device, it could use a LiDAR type of laser to scan your environment and display a mesh. If you go back a few slides, that is kind of similar to a mesh mapped on a physical environment here. Yeah, so let's go back here. So one of the questions to solve would be how to make a plane, and there are a lot of different approaches to do that. You could just try to define 3 corners of a plane. Making a plane is relevant because the 3D scan of your environment is not exactly precise. Then you can select more points and average out this 3D plane equation, or you could follow the mesh from a central point to start a plane, or you could snap to so-called voxel grid. Yeah. Spatial understanding now would be reasoning about what can be derived from the spatial meshes. That could be identifying the wall, or find seatable furniture such as this chair, find the ceiling, or find free space in order to, for example, place virtual objects in proper locations. And how is it done? Like behind the scenes, there's a lot of manipulation and math, magic and logic on the spatial mesh. There could be accelerated processing on the silicon, for example, on HoloLens 2, or it could use pre-trained AI models to recognize some types of objects. Yeah. Now, to give you an example of some code that actually is available for HoloLens 1 and 2, there's a spatial understanding library. That would be a type of query you could ask, like basically find something that is between height of 25 centimeters and 60 centimeters, has one surface at least, has at least a surface of that many square meters, is a rectangle, and then the length of the rectangle is this, and it's not this other type of object we have to find somewhere else. So it would be a very, very complex set of rules, but it sits on top of like a lot of calculations. Like you would count topologies, and you do that by finding topology analyzer and then find surface normals and all types of fancy things that as a developer you probably wouldn't even want to do. That's why there's a library to do that, right? On HoloLens 2, there's scene understanding, which is similar to spatial understanding, but it's a little bit decoupled. There's a scene understanding runtime that actually runs on HoloLens 2 and is partially accelerated by the silicon. And you can ask that scene understanding runtime specific things, like give me, for example, background, give me the floor, give me the ceiling, give me a platform. Yeah. Now there's some resources I want to look at what that is, so I will not spend too much time on that, but show you like a little video what I mean with spatial understanding. I will actually use the example that would also work with HoloLens 1. Video is pretty big. So in this example here, it starts with scanning the room, right? So the app starts and it will start scanning the room. And as you scan the room, it will start recognizing and then skipping ahead. It would recognize objects based on the depth camera that your device has. And other systems, other AR systems use similar approaches. So they basically, and you want to look at something longer, so it fills it, right? So over time, we're filling the whole environment and scanning everything. Yeah, so you see, but you see it's not exactly precise. You know, those inaccuracies there. That's why you need to process what was scanned later on. So at around 6 minutes 60, we're happy, and now we're finalizing the scan. It does some last processing, and then we can ask now the system queries. Yeah, and some of the queries may be, for example, find something sittable. Yeah, we making a query and it shows it finds those sittable surfaces. I'm stopping here. For example, it found those chairs based on those rules I displayed before. Yeah, so you could now position an avatar and make that avatar sit on that surface. Yeah, that's not a cloud capability, but that's a capability of something that runs on your device typically. But you could theoretically also build a cloud version of it if you want to. This is just standard code working on a 3D representation of that mesh. Yeah. Another query would be find, what's that a good query? Find, yeah, put something on the edge of the surface. That's a good one here. It was very clumsy to click when I did that. So it positions a lot of objects in the space, but always on the edge of a surface, right? So it has some rules for that. So it finds locations on a large enough surface where you can position something. Another query could be find find large areas on a space, on the floor, or find the largest wall in the room that could be used, for example, to put a virtual screen on a room, on a wall. So that's just an overview of some of the things you can do when you do some type of spatial understandings. And different platforms may have different systems for doing that. So this was basically for HoloLens. Now, let's go back to the cloud. Unfortunately, we don't have a lot of innovation yet coming out in front of from the mesh team that's available to us. What we have currently as cloud capabilities that are specific to, let's say, MetaVerse. Of course, you could also use cognitive services and Azure Cognitive Services and just do image recognition and things like that. But more specifically around 3D or mixed reality, we have Azure Spatial Anchors, Azure Object Anchors, and Azure Remote Rendering. Yeah. So let's first look at my headline got the wrong color. It doesn't render, but this is Azure Remote Rendering. This is when details matter. How it works is you basically upload a 3D model into the cloud. It does pre-processing for you, and then you stream the rendered model to device. And so you consume a lot of processing power on the cloud, but then even on a mobile hardware like a HoloLens, you can get a very, very high polygon count, which otherwise would be limited by your hardware, and very, very high visual fidelity, and render that on your device. Here's a rough overview about how it would work. Well, behind the scenes, you need to set up the resources in Azure, of course, but what it does, it instantiates an Azure VM that hosts this whole service. You interact with the web browser, and in the tooling API, upload the model you're interested in, and then from the client, the game engine on HoloLens 2, you would use the client API and talk to the renderer this way. The other example, and again, sorry that my title doesn't work, would be Azure Object Anchors. Here, the problem to solve is we want to lock to a physical object without knowing the precise location ahead of time in 3D space, and we don't want to put like a barcode on it. So how to work this? Let's look at this car on the right side. Imagine you have a 3D model of that car. You would upload that. It does pre-processing in the cloud. Then you can at runtime precisely locate the real-world object to display content relative to it. Yeah, again, you have a 3D asset, you uploaded it, then it does a conversion job, then it downloads it in the object anchor model, you put that on your HoloLens device, and that HoloLens device is then able to snap things relative to that car. For example, the location of some cables and whatnot. Yeah, that's the overview of the processing flow again. Now, the Azure Spatial Anchors concept is what I want to dive a little bit more into. Is, for example, first of all, what is the Azure Spatial Anchor? First of all, in general, it's a spatial anchor, and here's actually a rendition of what the spatial anchor may look like. Here's a 3D environment, and if you use a device that's like HoloLens, internally it creates a representation of what it sees by assigning feature points in 3D, basically a so-called sparse point cloud, basically things that matter, things that help it to locate something in 3D space. Now, this Azure Spatial Anchor system, however, is not just able to store a spatial anchor from HoloLens, it's also able to translate between AR environments. So you could anchor something on a HoloLens 2 device and then use an Android device or an iOS device and find it again. Yeah, it does that by representing or uploading this point cloud to the cloud, representing all those location as a type of hash. So it is private in that sense that the system doesn't have a real idea how things look like. So it will not steal your layouts from you, but it has a type of magic juju hash. They don't disclose the algorithm, how it's able to relocate those feature points, three-dimensional feature points in the cloud. So creating using a spatial anchor, like first of all, and I will skip to that really quickly because it's not so exciting, you would need to create an Azure resource, and you would give it a name and where it runs. Then you can give it a tag so you can find it in your queries if you want to, and then you create the whole thing. Yeah. Now, as the deployment goes, when you're done, you can look at the details of it. And the details are here. The relevant part is the following: the account ID, you need to know that. You need to know the account domain. That's basically a domain name, corresponds to where your resource is hosted. And then you have those access keys that you, access by clicking access keys. Yeah. And those you need to use in the application to hook up things with the application. Yeah. So now, what are the concepts to interact with that? And I will only, I try to do debugging, but debugging in a live session of this length really didn't work well. So I will walk through pseudocode here and then show you a little bit of a video at the end. Sorry about that. So we have the concept of a session, the session to interact with the anchors, the spatial anchor, Azure Spatial Anchor. Then we provide frames to that session, meaning frames from a camera that understands your environment. HoloLens uses an internal method. Then anchors get created, and those anchors can have properties. Then sessions provide anchor relationships, meaning you create 2 or 3 anchors in the same session. Then those anchors would be able to be found by the system automatically by saying, hey, give me those anchors for the session. And let's say you find an anchor you knew previously, and then create a new anchor. Then even though you have a new session, because every time you start again with adding anchors, it creates a new session, it also will build relationships. Then it has a coarse lookup. We'll talk about that, what that is briefly, and when we get there. And that can help you to locate things when you do not know precisely how you anchor IDs, and find things relevant to you in that environment. And then you can retrieve anchors by identifiers, relationships, or coarse location. Now, briefly, how it works as in code would be, as a developer, you would initialize a Cloud Spatial Anchor session, and this is Unity 3D SDK code. The SDKs for native systems or Android native Android and so on may look slightly different. And then depending on what you hook this up with your local AR subsystem. On Unity iOS would be like this, on for example, on Android like this also. And in UWP for HoloLens, we don't need it basically because it knows that it uses the HoloLens subsystem. And so in order to understand your environment, while HoloLens has this runtime that does it automatically, you need to hook up your AR, your camera system with that spatial anchor runtime that runs on a device. It, in a way, mimics what HoloLens 2 does automatically, building this point cloud for you. Yeah. And so how it works then, you add a component to a so-called game object. That's the cloud native anchor. Think about it as the link up between the native things running on your device and what's needed in the cloud. Yeah, then you get that cloud native anchor, and then you can create that corresponding object in the cloud. Yeah, by calling the cloud session create anchor. This one, after it's done, has an identifier, a unique ID that you can store then somewhere, and you can use that to later on retrieve that anchor. So really you want to remember or store that somewhere. That's important to know. The other thing you can do, those anchors, they can have properties like, let's say, metadata of all types, basically this text and labels, and you can add them, and they get persisted when you created an anchor, or you can also update them later on by calling an update method. And finally, you can modify properties even if you do not previously locate the anchor. Okay, why does it matter? You may have a some server-side code or something that runs that's not able running on a system where you retrieve your actual physical anchors, but you want to do bulk update and so on. So you could ask the system, just give me the anchor by this property, by this anchor ID, those anchor properties, and then you modify them. Yeah. Now how does it work when you want to locate something? Yeah. So what you do is you create a so-called watcher, and you create that watcher with the identifiers of the anchors you're interested in. Remember the identifiers from earlier, assuming you have saved them somewhere. You can provide up to 35 for one watcher, and then you hook up an event handler with that, and that event handler will be fired for every of those IDs that you provided. And depending on what happens in the system, if it's successful, you get the anchor status located event, and then you can get the position and all the data from the anchor here, right here where it is. And you may already know the anchor in your system, then you just gets the information, you can go on. You don't need to do anything. It could also be that you're asking for an ID that the cloud system doesn't know about it, or it can happen that after a while, the anchor you were interested in has not been found. Yeah, it can take time for an anchor to be actually found, so this event may fire a little bit delayed. Yeah. Now the other aspect is the coarse relocation. You can. The question is, what do you do when you walk in a new environment and like basically ask, show me what's interesting here? Yeah, and people ask, hey, what's my GPS for HoloLens? Well, for example, some devices do not have GPS like HoloLens, so that Spatial Anchors team came up with a system. They call it the sensor fingerprint provider that can be used to associate sensor data from your devices with anchors. And the sensor data could be the GPS coordinate that may be known. It could be Wi-Fi hotspots and Wi-Fi data, including signal strengths that have been measured around where that anchor was created. Or it could be BLE beacons, Bluetooth low energy beacons that may have an ID. That may be nearby. Yeah. Behind the scenes, it creates internal representation and a hash for that, and can persist that with the anchor. And then you can query with the so-called coarse relocation for nearby anchors. And you see, not every system supports everything. For example, iOS doesn't support Wi-Fi as a localization method because iOS doesn't expose currently in the API the Wi-Fi signal strengths to developers. May change in the future, but that's the latest state we have. And on HoloLens, by default, you do not have GPS. There is, however, a way to hook up an external GPS device. I haven't tried it out, but the documentation provides a hook to that. So you can combine all those things together. Yeah. Now, like a little demo, how would it look like when you run it? Starting a video again. Now, when you run this would be the HoloLens application. When you start the anchor session, and then it takes a little bit to process, and then you place something. Yeah, now I placed it in 3D space and save it to the cloud. And then I stop that session. Then I create a query session and I know my ID. So I ask for that ID and I look for that anchor. Takes a bit, and it found it. Yeah. I mean, the code steps would be the exact code step that I've shown you before. The other part is nearby. How do you find nearby? Sorry. How do you find nearby anchors? Would be you place in an anchor session, several of those anchors. Yeah. And then it's stored. And now we found the first anchor by the ID, and then we found the other anchors that were related to that anchor also with the API calls. I don't have sample code for that nearby to show right now. There are, however, resources to look that up. Everything has good samples and demos. Actually, this is a out-of-the-box demo that you can just run when you download the SDK samples. Now, what I did here is, let's pause for a second. Here, I want to do coarse lookup. Yeah, I mean, here I stored an anchor in my real space. And now, okay, I forget about everything. Remember, I stored it approximately around here. And now I want to create an Azure Spatial Anchor session for the query and do the Spatial Anchors session, the coarse query. Find me everything that's interesting around here. And I found all those previous anchors that I was placed earlier. Yeah, all those things here. Now, in the app, you can then delete the last anchor, but those other anchors would still exist in the cloud systems and could be retrieved by anybody who would want to, like 5 in total in that environment. Yeah, you can distinguish in those queries how far from your location you're interested in anchors. Let's say you could say, I only want to find things far away is 5 meters from my location or 25 meters and so on. Okay. Then let's briefly look at the Azure portal. I hope, of course, I closed my Azure portal login. So I'm going to log in off screen. If you don't see anything happening, please be patient. Portal Azure. It's when you're presenting, I usually try not to have too many things open before. I start the session to not get weird notifications popping up and so on, but the downside is that logging in may take a bit. Windows open, it's connecting to Azure. Okay, it's loading my the Azure portal now. Okay, forget about the recommendations. And here already, if you look at Azure Spatial Anchors accounts, it would know that I set up the Azure Spatial Anchors resource. Just did that today. And here I can look at the details. Let's zoom in a little bit. Let's go to monitoring to see what happened. So let's see what happened in the last 6 hours. You see that I created around 8 anchors when I was recording the video earlier. And this is representative and here I deleted 3 anchors. There's a CC that corresponds to the 5 anchors that still existed, and I did in total 15 anchor lookups that were found. Yeah. I can have also other queries here, but this is the Azure portal representation of the whole thing. Okay, so with this, I'm pretty much through with what I wanted to show today. So I will open the floor for questions. I believe we have still about 5 to maybe 8 minutes only, max. And this is what I had for content. Again, unfortunately, some things in the metaverse are a little bit slower than I would wish for. So all the things with Microsoft Mesh will probably come out in the future. If I were you, I would closely look at what Outspace VR is doing and what Teams are doing, because those teams and Outspace VR teams are very active in incorporating Microsoft Mesh technologies.